graphs of y is equal to negative f of x and y is equal to f of negative x. So I looked at the square root function because it's sometimes the easiest one to see this transformation, and we know the graph of the square root function is this. Well, I've looked at what negative f of x is, right? Negative f of x, that is an outside change. In other words, it is affecting the y values. Because remember, on our square root function we have the 0.11, the 0.42. Well, on negative square root of x, notice what happens. The graph flips over the x-axis. Because now we have the 0.1, negative 1, and 4, negative 2. See, the y values are changed, the x values stay the same. So the graph, I'll say real mathematical terms here, it flipped over the x-axis. There is actually a precise mathematical term for that, and I'll show you that in just a minute. What happens if we change the x values? That is, we take the opposite of the x. So here we have an inside change, and we would expect an effect on the x values. And notice the effect of the domain and range, and I'll talk about that too. The square root of negative x, so remember that f of negative x means to replace x with negative x, which is exactly what I did here, and look at the graph of this. It did what? It flipped the graph, so we're comparing it to the original function here. So what's going here, but now when we did it, the square root of negative x is going here. So it actually flipped the graph over the y-axis. What is domain and range? Let's just talk about that. Original function domain from left to right is 0 to infinity. The range is bottom up, which is also 0 to infinity. Because remember that point 0, 0 is my bottommost and my leftmost point. For the negative square root of x, the domain is still 0 to infinity because the leftmost point is at 0, 0 and it's continuing to the right. Now the range is affected here, and we would expect that because the y values were changed. Now it's going from negative infinity up to 0. For this transformed graph, my domain was affected, which is what I would expect since the x value was changed. It's from negative infinity to 0. Now the range was not affected because we didn't change the y. It's from 0 to infinity. Okay? So let's make a conclusion here about the true name that we can call this. The graph of y is equal to f of negative x is a reflection of the graph of f across the y-axis. So when we're inside changing the x values, we're reflecting across the y-axis, because if you think about this, okay, if my x values are positive here, right, when I flip them over the y, they become negative. And that's what we're doing, right? We're taking the opposite of x. Well, the opposite of x are on the opposite side of the y-axis. So that term reflection is a real mathematical term for flipping over the x. It's kind of like a mirror image, right? If you see your mirror image, you're seeing the opposite of what you would think. The graph of y is equal to negative f of x is a reflection of the graph of f across the x-axis. Why is that? Because if we're changing the y values, here the y values are positive, but they have to be flipped over the x to become negative. So we're flipping it over to take the reflection. And I'm looking at a few examples just again so you can get a picture of that. And I've started with this function, y is equal to the quantity x minus 2 squared. So that's one of the shiftings of the parabola, but it doesn't really even matter. I'm just trying to start with one function and then taking the negative x inside and then the negative on the outside. So this is just a picture of my original function, if you will. So let's look at what happens if we take the opposite of that. So this is really the same thing as y is equal to the opposite of f of x. So if we're thinking about this as being my function f of x, y is equal to negative f of x. So this is changing the y values, right? Taking the opposite of the y. And you can see that in the table. My x values were not changed, but my y values were all opposites there. And in doing that, that's going to flip the graph over the x-axis. So this is a reflection across the x-axis. Right, you can see that. If you even had a picture or a piece of paper rather, and you had this graph drawn on the paper, and you folded that graph on the x-axis, or even you flipped it over vertically, you're going to get a reflection of that graph. Now let's look at what happens if we replace x with negative x. So this one is really y is equal to f of negative x. Notice what happened. Now the graph went from on the right side of the y-axis to the left side. It flipped over the y-axis. So this is a reflection across the y-axis. So it's interesting to note what happens here. Like if this 3, 1 is on the graph of the original function, notice what's here. It's negative 3, 1. So my x values were opposite, but my y values stayed the same. I can do that over here too. If 3, 1 was here, what was on this graph? It was 3, negative 1. So in this first case, the x stayed the same, the y was opposite. In the other case, the x was the opposite and y stayed the same.